We back in the lab, we making some noise, so go turn your decibels up. Black skin, white coat, oh no, who was nice as us? Made Jemison, really told us no limit, so we about to take us up. Went from mixing in the kitchen to the lab, and now I can make this up. Whoa! B-SCI, be scientist, B-SCI, be scientist. We shining a light on the people of color to show them how fly it is. B-SCI, be scientist, B-SCI, be scientist. We back in the lab with white coats on our back, trying to show what time it is. Hey!
Hello friends, and welcome back to the B-Scientist podcast, a podcast by the Black Science Coalition and Institute, or B-SCI. When you hear this noise, that is our in-podcast citation. And if you'd like to learn more about all of our citations, you can go to b-sci.org and see all of our citations ever. I am your resident chemist, Jana Carpenter, and I am not joined by my co-host Jordan Chapman, but no worries, he is settling in at Baylor University. I did want to come on and tell you about all of my travels this summer. So I started in Costa Rica, and then I went to Ecuador, and well, let's just say there's a lot to learn and even more to enjoy. So if you like chocolate, if you like travel, and you love supporting Black scientists, then tune in. So to properly tell this story, I kind of need to start from the beginning. So in our department, we regularly get emails from our graduate coordinator about opportunities and scholarships that graduate students are eligible for. So naturally, I read my emails one day and saw that there was an NSF-funded scholarship for a graduate student who had analytical chemistry background, some metabolomics research, and then some aspect of other technical abilities in chemistry. So the scholarship itself is known as an NSF IRES, which is an international research grant funded by the NSF, the National Science Foundation, which is a pretty big deal if you are in the academic field or really any other big scientific research program. And so I decided to apply and met with the research coordinator of the project, and we got along really well. He did say that I needed to learn some Spanish, so that was a little daunting because I don't think I have taken a Spanish class since probably middle school, but my brother Nikita Carpenter Jr. Has some pretty good Spanish skills. So I told myself that, okay, maybe I can do this. I don't know. You know, I'm a second year PhD student and going out for this NSF-funded research project that is somewhat similar to what I am studying, but also really, really different, and also it just so happens to be in another country. And I'd have to take off a few months from research. So there's just a lot of variables that I had to take into account when applying for this, but I just couldn't pass up the opportunity. One, because it's just great to be able to get funded to go somewhere new, especially South America and other parts of Central America. I mean, I don't know about you, but if someone told me that they would pay me to do what I love and also see parts of the world that I've never seen before, I would say yeah. So I talked to my advisor and she was all for it. And oh yeah, I forgot to mention the research. So I hope that by the end of this podcast, you'll learn a thing or two about one very important metabolite called theobromine. Theobromine just so happens to be a really special metabolite that looks structurally similar to caffeine. So I know you've probably heard of caffeine because it's the one molecule that helps us to get going. Maybe you take your caffeine in the medium of coffee or tea, or maybe even energy drinks if that's your vibe. I don't know your life, But either way, theobromine is this really feel-good molecule that actually occurs naturally in cacao. Yep, that's right. We're talking about chocolate. So, to bring this back to the story, the research project that this scholarship funded was to, for my aspect at least, look into the fermentation aspects that contribute to desirable metabolites from cacao fermentation. And so this means that I would be looking at metabolites that are specifically going to register in the parts of your brain to be really delicious. So these are going to register all of your feel-good serotonin, maybe some oxytocin, depending on how passionate you are about chocolate, and just other parts of your brain that register as desire from chocolate. So my aspect of the project was to annotate all of the volatile compounds, which are going to be these desirable compounds in chocolate. And so the major method for doing that is utilizing an analytical technique called gas chromatography mass spec, GCMS. So this type of analytical technique actually turns the molecules into the gas phase, and then we measure the ions of these molecules, and then we can gather these measurements to verify their masses in the gas phase, and they're all separated through retention time and chromatography, and then we can analyze them, quantitate them, and then say, okay, if we do this type of condition, we'll get this amount of this molecule. So if that makes sense to you, great. If not, I'll try to go into a little bit more detail later on. But essentially, I was the person who needed to come up with a really creative way and efficient way of analyzing these really essential compounds in chocolate. And so the other parts of this project also looked into other external ways of creating a really desirable product, right? Because people really love chocolate. I know I do. But there's so many different aspects of it that you really have to look into to make sure you're kind of looking at everything in an unbiased way, right? So the other aspects of this project looked into the bacteria and the fungi that help to cultivate a really good fermentation. So there are many aspects of fermentation that I won't go into today because it's just way too complex. But essentially, cacao itself is a plant, and that plant has what's known as mucilage. So this mucilage is this white and sticky fleshy substance that surrounds the cacao beans within the fruit itself. This is our golden ticket. If you're a Willy Wonka fan, you will get it, okay? These cacao beans undergo a series of fermentations, and then at the end of the process, all the way at the end of the processing line, you get this really amazing chocolate product, right? So you start first by fermentation. So fermentation can only occur when there is a microorganism causing some type of reaction to happen. And so bacteria and fungi actually help us to create a really nice end product. And you can taste it actually, because they create these compounds that we really love in a chocolate. So we looked into some different species of bacteria that are known to occur spontaneously in fermentation, along with fungi. And we wanted to optimize this process to create even more efficiently produced delicious chocolate. Okay, so that's one aspect. We have our way of quantifying really good metabolites that occur in good chocolate, and then we also have the beginning part of the process. How do these organisms contribute to this nice flavor profile? Another aspect of it also looked into the fermentation containers themselves, right? So fermentation is really an exothermic reaction, which just means that it's going to give off a lot of heat in the process. So we wanted to find a way to create a vessel that was really capable of maintaining a temperature that was compatible with a desirable fermentation process. So there's lots of literature based on good fermentation and what that means, but really no one knows what it means because there's just not enough research done in this area to kind of fully grasp what it means to have a good fermentation. And so that brings us to the first leg of my journey, which started in Costa Rica. And so a part of this NSF grant allowed me to take a UGA course called Choco-Rica. And I know what you're thinking, how cliche. Well, yeah, that's what it was called. And I'm not complaining because I did not have to pay for it. So this first part of the journey was really a way for us to get familiar with the historical, cultural, and societal aspects of chocolate, really. Because I know that if you walk into a grocery store or even a gas station, you're bound to find some form of chocolate somewhere, right? Whether it's your Hershey or your Mars bar or what have you, you'll find it just really anywhere around the corner. And so the first leg of my journey started at the very top of Costa Rica, or at least, I guess I should say like the top third portion of Costa Rica in Guanacaste. So what you should know about Costa Rica is that it is composed of 7 different provinces, and we almost traveled to every single one of them along the western side of Costa Rica, which was pretty impressive. So this trip started in Guanacaste. It was a 2-week trip, and the goal of the trip was to start at the lower level producers and then work our way up to large manufacturers of chocolate. And so that's exactly what we did. We started in Guanacaste and we got to meet producer Edwin. Edwin Cibaja lives on a small plot of land in Guatuso in the outskirts of Upala, and he pretty much tills the land almost entirely independently. Some of his family members help him to till the land, but really at the end of the day, Edwin is just really devoted to his agriculture. And so he has several crops. So we pull up to his plot of land and we get to meet him. He's so friendly. He shows us, where he lives, his chickens, and then he gets to show us his real life experiments. And the scientist in me is just so excited because he's actively doing research all the time. And so the outsider would look at him and say, oh, he's an agricultural producer. But in my mind, he's a scientist, okay? So what he's essentially doing is creating different hybrids of really high quality producing cacao. So although we know that cacao can be manipulated in ways to create these delicious metabolites with bacteria, fungi, and fermenters, it can also be highly influenced by the type of cacao that you're growing. So there are several different varietals of cacao actually, and this is just different genetic species of cacao that are structurally similar but have different genetic outputs to create slightly different cacao. So the big three are Forastero, Criollo, and the Trinitario, which are all different types of cacao. Trinitario in particular is a hybrid of Criollo and Forastero cacao. So that's the only ounce of Spanish that I will give you, and that's all you get because I'm not good at this. But these all create some form of delicious chocolate. So the Criollo is known as some of the best varietal of cacao, while the Trinitario is very good at producing a mass quantity of slightly delicious cacao, all depending on who you are as a manufacturer. And the Forastero is actually the varietal of cacao that is produced in bulk. So this is going to be your cacao powders and maybe your Hershey bars, things that are really made in mass. But of course, as we all know, things of high quality are usually in high demand but low product. So that is where we started our journey in Costa Rica. And what's really important to note is that in order to create really good chocolate, you have to have a good foundation. But there's a huge societal and economical difference in those producers of really high quality cacao versus bulk cacao. So if you look around the world at the major producers of cacao, a majority of it does come from Africa, and then a very small portion of it comes from Costa Rica, and an even smaller portion of that comes from Ecuador, which, from what we know, is some of the origins of cacao in Ecuador or regions in South America / Central America. And so a large part of this first trip was, of course, to learn about some of the origins of mass-produced cacao and learning about going from a small farm to a large manufacturer. But another aspect of this project was to understand how the effects of cacao production itself creates a huge divide between the producers of cacao, the Edwins, who go out and create these beautiful varietals, hybrids of cacao to create the most delicious end product, to the manufacturers themselves who are actually making the most money from this agricultural product. And so in large part, yes, this project was to find ways of creating a really delicious product, but on the other hand, we really wanted to find a way to create an efficient and effective technique to create delicious cacao on a very accessible level. So whether or not you had a small farm versus a huge production farm, we wanted to be able to provide an easy workflow to create high quality chocolate in the end. And so this trip was really quite emotional for me because there were a lot of instances where we got to really see the disparities in these lower level producers versus these high production manufacturers. But in the end, everyone is truly so incredible in Costa Rica, and I think if I could, I would definitely live there. There were just so many sights to see. We were able to experience so many nice explorations in nature, and I highly recommend it if you ever get the chance. I won't say one part of Costa Rica over the other. I think in all, the entire country is just absolutely beautiful. But so, I'm getting off track. We did start in Guanacaste, and we kind of just worked our way down to San Jose, the capital. And on our way, we started at a modest farm with Edwin. And we went to a larger producer called La Dorada, which they create a lot of really fine quality cacao to be sent off to manufacturers to then be turned into chocolate. So they really just sell their fermented beans. And then after that, we went to Nawa, which is a slightly larger manufacturer where they actually take the fermented beans and then they create the chocolate on site. And so what I really, really liked about Nawa is that not only was the chocolate absolutely amazing, but they also are really inclusive. And so their whole business idea is to pay these producers from modest farms and also have some equity amongst the producers. So they're really working with a lot of the local farmers who are producing and procuring these beans in Costa Rica, in Costa Rican climate, and that way they're achieving really ideal, consistent quality results and standards. And so they have a host of different smallholder farmers that they are not only providing an equitable source of income, but they're also supporting community engagement. And then they also have a really strong focus in environment and promoting sustainable farming practices. So they were by far my favorite of all of the companies to tour. And then the last company that is essentially the largest producer or manufacturer of chocolate is Herrick's. And so you can think of Herrick's a lot like how you would think of Hershey. So even down to their font looked so similar to Hershey. And they had some really delicious chocolate also. But I just love something about Nawa and their mission statement and the impact that they make on all of the local smallholder farmers around Costa Rica. They really do put the people first, and that creates this really delicious chocolate. Not only because the chocolate itself is good, but because you feel good knowing that the people behind the chocolate itself, the people who are creating this chocolate, are also being taken care of and shown some respect. So that was my Costa Rica trip. Honestly, this is a shotgun overview of that trip. It was only 2 weeks, but it felt like a lifetime because there was so much to see, there was so much to experience, and I got to see and experience a whole other world of chocolate that I never fully understood before. So that was incredible. And I just want to shout out Gata, who was our guide on the tour. She was amazing and so patient. And also we stayed at the Catalina Lodge in Guanacaste. Amazing, beautiful views, amazing people. Everything was family style. So overall, 10 out of 10 experience. I got to learn about a lot of the, behind the scenes processes of what it takes to even produce cacao in the first place. And so that brings us to the second half, which will be a lot shorter than the Costa Rica explanation. And that's because I was supposed to spend 8 weeks in Ecuador after the Costa Rica trip to begin my research, looking at the Criollo varietal of cacao originally found in Ecuador. So I know what you're wondering. What does theobromine have to do with any of this? Okay, I'm sorry. Let's get to that. So, in Ecuador, we were supposed to stay at La Escuela Superior Politécnica del Litoral, or ESPOL, in Guayaquil, Ecuador, which is a really large university. It sits on a plot of over 7 acres of land, and they do a lot of environmental, technological research here at their facilities. And so we were going to utilize a lot of their scientific research facilities to do a lot of our quantitation. And so the idea was to get varietals of Criollo around the Guayaquil area and do our analytical techniques utilizing gas chromatography and quantitating these desirable metabolites. And so what does theobromine have to do with this? Well, gas chromatography is actually really good at separating out what is known as a metabolite class called polyphenols. Now, these polyphenols are a secondary metabolite of microbial production, and it can be found in fruits, nuts, red wine, and of course, chocolate. And so my whole project was going to look into the profiles of all of these volatile compounds, these fleeting compounds, if you will, much like the name suggests, of these flavor profiles that relate to desirable qualities in high quality chocolate. And so we get to Ecuador, and before we arrive, we kind of already know that there are protests going on, and we know that the protest involved indigenous groups from the Confederation of Indigenous Nationalities of Ecuador, and the protests were really launched against the Ecuadorian government, with the increase to fuel and food prices, along with increased inflation due to the pandemic and other external influences like the war in Ukraine. But I really won't go into the politics of what all of that meant. In terms of our being there, it just became a situation where we really didn't fully feel safe, and this was an incident that didn't involve us at all, really. And so we stayed in Quito, and there were a couple of incidents in the city. We did eventually get to Guayaquil, where protests hadn't really traveled to at the time. But over the weekend that we stayed there, which was in June, about June 20th or so, we did notice that the situation was progressing. And so at that time, even though we were geared up to get started with research and starting our projects, we really just decided that it wasn't smart to stay in the country, especially when our research really was impacted by the surrounding protests around the country. And so after about 2.5 weeks, we did decide to cancel our research program in Ecuador, and we came back to the United States. But I did get a lot of really useful information out of the entire project. I really was able to learn a lot more about cacao and cacao fermentation, and that there are just so many different aspects of it that we still don't fully understand. And so fully developing different techniques to produce these polyphenols, these volatile compounds that are characteristic in chocolate flavors, are primarily produced during fermentation. And so one major thing that I did want to expound upon is the actual fermentation process. Since I wasn't able to get data from this project, the fermentation itself is something that we did go over thoroughly in our time in Costa Rica. And so really fermentation, like I mentioned previously, is this spontaneous reaction that is not well understood, and honestly it's not done in a uniform fashion across all different mass producers and smallholder farmers. And so getting a grasp on fermentation is pretty difficult because it is a spontaneous reaction. And when I say spontaneous, I mean you break open the cacao pod itself, you take it off of the tree, and the mucilage, this pulpy flesh surrounding the seeds, actually has a nice high sugar concentration, and that sugar is actually going to help jumpstart the fermentation process. So yes, we are making alcohol in this process, and the alcohols produced in the fermentation process will then be in turn fuel for bacteria in the second part of the fermentation. And that bacteria are really going to drive some of the components of the polyphenols that are desirable. And so this really sweet spot between alcohol or anaerobic fermentation to aerobic fermentation, where it's being done with bacteria is really crucial in understanding how flavor is being produced. And so how many days, how many hours, right? It really depends on the producer, and it also depends on the manufacturer. So it depends on what they want. So we do have, luckily, a lot of really dense information about the genome or the genetics of the different varietals that we know and love today. And there was one institution in Costa Rica, CATIE, that actually will document all of these different genomic varietals. And so different varietals behave differently under different fermentation conditions. But generally speaking, across the literature, you'll probably find anywhere between a 3 and 5 day fermentation. 5 days, between 3 and 5 days, that's a long time. And so you really want to be able to do this in a way that is efficient, because if your end product turns out to have really bitter notes or notes that just aren't very desirable in a final product of chocolate, it can be really detrimental to selling it, right? Because we want to be able to in turn sell it to manufacturers who will then pay you a premium on the cacao that you've produced and fermented. And so, like I kind of mentioned earlier, between day 1 and 2, and sometimes longer depending on the conditions, that is when we have anaerobic fermentation. And so this is when we don't have oxygen feeding our reaction. And so oxygen can be a really nice catalyst for fermentation when the conditions are suitable for the organism that is undergoing the fermentation process. But in the first 2 days, that is when we have our Saccharomyces cerevisiae, and you might have heard of this organism, this fungi, if you've ever had beer or even wine. It's a really great organism for jump-starting anaerobic fermentation, and so lots of varietals of this particular organism will jumpstart that process. And then somewhere between 2 to 4 days, we will undergo the aerobic portion of fermentation, which is when you have your bacteria, which really we haven't zoned in on one specific organism. There are a variety of different organisms, but they all will feed on the alcohol produced in the first half of fermentation that is done, the anaerobic fermentation. And so during aerobic fermentation, when we have bacteria, this bacteria is then changing the proteins, the protein components of cacao, and creating these polyphenols to have this end product that we really desire, this chocolate. And so in the final day of fermentation, on the 5th day, the final day, that's really when we get to start seeing some color building in our cacao. So if you were to take a slice of cacao on each day of fermentation, it would start off looking either white or purple in the middle if you took a slice right down the middle. And then as the days progressed, it would slowly start to become more and more brown. This brown color should honestly look a lot like a chocolatey color. I don't know how else to describe it in a way that's still desirable. But that's the end result that we're looking for. That's kind of what the last day is for, to finalize some of that fermentation and to make sure that there's no more raw parts of the cacao pod itself. And so after this fermentation process, you then go into chocolate production, right? And that's a whole other episode that we'll have to cover later, because every part of this process is so incredibly intricate, and there's like maybe 50 different moving parts all to cover. But I did just want to give you kind of a snippet of my research, and also what could have been with my Ecuador research project. But in the end, I was still able to get really an amazing experience, and one that I'll never forget. And I'm just honestly so thankful that I was able to have this experience and be able to tell you about it today. So if you found this to be interesting, I want you to think about the last time you had chocolate, and I want you to think to yourself, what does chocolate actually taste like? What is the flavor that it gives you? And you can't say chocolate because that's too on the nose. But next time you eat a piece of chocolate, I really want you to think about this theobromine molecule that looks a whole lot like caffeine. And I want you to think about the aspects of chocolate that make you happy, that give you a desire for chocolate, and what it means to you. Because I was able to learn a lot about what chocolate means to me. And now I know that I don't think I could live without it. And I don't know too many people who can, but either way, I hope you learned something today. And if you like what you heard, please let me know if you would like to learn more about chocolate and the chocolate making process. We will do another episode later on and do a more deep dive. And I just would appreciate any feedback that you have for us. B-SCI has a lot of things in the works right now, so we're hoping to get our magazine out soon, and we would love to have you submit. So just head to the B-SCI.org website to post your submissions, and I think that's all I've got for you today. But don't forget to follow us on social media and let us know what you think. We'll be back next time with our other co-host, Jordan Chapman. And until then, don't forget to be scientist.
Be Scientist is a podcast by the Black Science Coalition and Institute, or B-SCI, a 501c3 nonprofit. Be Scientist is hosted by both Jana Carpenter, Chemist, and B-SCI's Research and Development Officer, and Jordan Chapman, geoarchaeologist and B-SCI's president. Music is produced by Delaralo, and lyrics are by Jana. Special thanks to Michael, Mike, Caston Marshall, and the Plaza Abbey Studios. If you'd like to donate to B-SCI, visit our official website, b-sci.org. That's b-sci.org. Your donation supports Be Scientist and B-SCI's other projects. We couldn't do it without you. So please tune in next time, and always be scientists.